Hey guys, in this video I want to go ahead and just kind of give you an introduction to matrices, some elementary row operations, and then also we'll go ahead and just probably do one example of Gaussian elimination. So what's a matrix? Well, it's just a rectangular array of rows and columns for the real numbers in order to solve some of these systems of equations, okay? Now the thing about matrices is that the order is important, okay? So the matrix is going to be set up like this, okay, with these brackets, and horizontal here, this is your row, okay, and then vertical is your column, okay. And if you ever see these subsets right here, A11, that means row 1, column 1. So row 1, column 1 is right there. This one is 2, 1 because it's the second row, column 1. And of course, row 3, column 1. Okay, and we always say a matrix is M times N or A times B. The first number is always the row, and the second number is always the column. Okay, so if you notice over here, I have some examples. So this guy is one row, but then there's two columns. Okay, so this is a 1 by 2 matrix. This guy, there's 1, 2, 3, 4 rows, only one column, so it's a 4 by 1. So the order is important because then later on we're going to be doing operations with matrices, and the order is important. And this guy is 2, 1, 2, 3 rows, and then 2 columns. So then this would be a 3 by 2. Okay. Now your professor might talk about what's something called augmented matrix. Okay. Now remember, the main purpose of these matrices is to solve these linear equations, okay, or linear systems. So what these are, an augmented matrix, guys. Let's say you have your original system here, an augmented matrix. All it is that you're going to write the matrix with the constant term on the right. Okay, you see the equals the 1, 3, and negative 2. That's what this is, an augmented matrix. Okay, the first row represents the x. The first column is the x. Second column is the y. Third column is the z. So this is your x variable, this is your y, and then this is your z. And of course, this is your constant, your answer. All right. The coefficient matrix, if you ever hear that, those are just the numbers in front of the variables, okay, without the constants, without these guys. So you notice exactly the same thing, except it doesn't have the equal sign. And that's it. Okay, now when we're talking about matrices, sometimes we're going to have to manipulate them to add them to other rows. So we have these elementary, what we call row operations, okay? And these are going to be useful in solving matrices later on. And I'll give you one example. So one of the things that we can do is interchanging the two equations, so kind of flipping them, okay? And if you notice for this one here, this is the original matrix, right? So this is row 1, row 2, row 3. And what I did with these two, I swapped them, I switched them. So this guy, 1, negative 3, 6, goes to the bottom, and 2, 1, negative 1 goes to the second row. So I swapped them. And I say interchanging, or sometimes your professors might say swapping. It means the same thing. Another thing you can do is you can multiply by a constant, okay, a multiplier. So if you can see here, this is the original matrix. And then what I did is I multiplied the first row, R1, times 2. So I got this guy, okay. So 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. And that's how I got this new matrix, okay. And lastly, last thing what we can do is also multiply and add the row to another row, okay. So add a multiple of an equation to another, okay. So what you can do here, you see this guy is 3r1 plus r3. So this means here is you took the first row, you multiplied it by 3, and then you added it to the third row, okay. So then this guy's right here is you're multiplying by 3, just to give you an idea, okay? You're multiplying it times 3. And then whatever you get there, you're going to be adding it to that third row, okay? Now, you got to be careful with these, because if you see numbers all over the place, you just got to be careful. So 3 times negative 1 is negative 3. Negative 3 plus 3 gives you what? 0, okay? 3 times 3, 9. 9 plus 1, 10. You see it's in the same column. 3 times 2, 6. 6 plus 5, 11. Okay? And this is an example of an augmented. So let me do my line here. Okay, so this is augmented. So these are the constants. 3 times 1 is 3. 3 plus 2 is 5. Okay, now I want you guys to notice something. See, this is the only one that changed, right, in the bottom. Okay, but look at this one, negative 1, 3, 2, 1. See, it stays the same. But I just used it to multiply by 3 in order to go ahead and add the bottom. Okay, and then what I'm doing is I'm manipulating it. Okay, so those are basic row operations. So now I want to go ahead and show you guys one example how we use these row operations using what's called Gaussian elimination after Carl Friedrich Gauss. So I went ahead and set up my augmented matrix. And the way Gaussian elimination works, guys, is you see this diagonal here, we want to go ahead and make them all ones. Okay, and then these here in this corner, we're going to make these 0. And the whole purpose is to start eliminating so we can end up with one variable in order to be able to solve for the other. Okay, now this is specific Gaussian elimination, which is very specific form. So remember, we're going to try to make these a 1 and these zeros. Now, how do you do that? Well, the first thing you're going to try to do is make this guy into a 1. Okay, either with a swap or multiplying or adding, something like that. So once we get this guy to be a 1, now we make these two a 0. And then we go to the next column. We make this guy a 1 and then try to make this guy into a 0. And then lastly, we're going to go ahead and try to make this guy into a 1 as well. And hopefully that this will be left and we'll be able to solve it. Okay, so if you notice here, this guy is a negative 1. So I'm going to swap this guy with this guy. But I'm going to go ahead and take the third row and I'm going to multiply it by negative 1. And I'm going to swap it with the first row. Okay, so that's what I'm going to go ahead and do first, just because I see there's a negative 1 there. Okay, so if I multiply, I'm going to go ahead and just put negative 1 there, just so I don't get confused. So I'm going to go ahead and this guy's going to go to the bottom, this guy's going to go on the top. The second row is going to be left the same, so let me go ahead and just start putting that one forward, negative 1, 3, and then it's going to be negative 7. Okay, so, and I know this guy is going to be in the bottom. I'm just swapping. I'm not doing anything. I'm just swapping it, switching it. Okay, negative 10. So I'm going to multiply this guy, and I'm just going to swap it with the first row. So negative times negative is a positive 1, so it becomes up here. Negative times 4. Negative 4 is swaps, so it's going to be here, negative 4. Negative times 0 is 0, and it just goes on the top. Negative 1 times 7 is negative 7, it goes on the top. Negative 7. All right, there we go. So that's my first thing. Now I made it into a 1, so now I'm going to try to make these into a 0. So what I'm going to do is I think I'm going to go ahead and multiply the third row times negative 2. And I'm going to add that guy to the second row. And then this guy is going to go over here in the second row. Okay, so I'm going to take the third row, multiply by negative 2, and then add it to this guy here. And that's going to be on the second row. So I'm going to go ahead and just put negative 2 here just for my sake. Okay, do that. All right, so what does that give me? So negative 2 times 2 is negative 4. Negative 4 plus 4 is 0. So this guy becomes a 0. So the first one up here stays the same. 1, negative 4, and 0. Okay. And then this guy becomes negative 7. All right. So then we continue. Negative 2 times negative 3 is 6. 6 take away 1 is 5. Okay. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. Negative 2 times negative 10 is 20. 20 take away 7 is 13. All right. Now, what about this guy? Remember, we just took care of replacing R2, the second row. This guy, I'm just going to leave it right now. Okay, nothing happened to that guy. I was just using that row to go ahead and change my matrix. Okay, so that's the next step. So now I got to make this guy into a 0. Okay, how am I going to make that into a 0? Well, I'm going to take the first row. I'm going to multiply him by negative 2. So if I multiply this guy by negative 2 and I add him to row 3, that's going to give me the 0 that I want. So that guy is going to go to the third row. Okay, so just go ahead and take your time. So the top row, I'm going to be multiplying them by negative 2. Okay, so Negative 2 times 1 is negative 2. Negative 2 plus the third row plus 2 is 0. So this guy becomes a 0. Notice this guy is going to stay the same. 5, negative 1, okay, and of course 13. All right, so this guy up here is going to stay the same. 1, negative 4, 0, negative 7. Okay, so negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 4 is positive 8. Take away 3 is 5. Negative 2 times 0 is 0. 0 plus 2 is 2. Negative 2 times negative 7 is 14. Minus 10 is 4. All right, so now I got that part. So I'm done with the first column. Now I'm going to try to make this guy into a 1. This guy right here. How do I make that guy into a 1? Well, I'm going to divide the second row by 5. So it's like multiplying by 1/5. And that guy is just going to stay in the second row. He's not going to go anywhere. Okay, so I'm going to multiply this whole thing by 1/5. 1/5 times 0 is still 0. 1/5 times 5 is 1. 1/5 times negative 1, that's negative 1/5. Okay, and then the last one, 13 divided by 5 is 13/5. Don't be afraid of the fractions. Hopefully they'll take care of themselves afterwards. Now the last row stays the same. 0, 5, 2, 4. The first row is 1, negative 4, and 0, and negative 7. Okay, that's my new one. Okay, so now I got to try to make this guy, this bottom here, into a 0. Okay, all right. So now let's go ahead. I think I'm going to go ahead and take my second row, multiply it by 5 or negative 5, and I add it to my third row. And that's going to go on my third row. Okay. And you can see how it could be, it's not very difficult, but just kind of be tedious, and you got to be careful because you have all these negatives flying around. So I'm going to multiply this guy by negative 5. Okay. And then I'm going to add them to the third. So negative 5 times 0 is 0. 0 plus 0, of course, is 0. Okay, right there. Negative 5 times 1 is negative 5. Negative 5 plus 5 is 0. Negative 5 times negative 1/5. Negative times negative is a positive. That becomes a positive 1. 1 plus 2 is 3. Okay, continue. Negative 5 times 13/5, that becomes negative 13. Negative 13 plus 4 is negative 9. Okay, now notice only the third row changed. Okay, only the third row. Well, what about this guy? Stays the same. 0, 1, negative 1/5, and then 13/5. Okay, what about the top? Stays the same. 1, negative 4, 0, and negative 7. Good. So now I have my new matrix. So notice 1, 0, 0, now 1, 0. Now I got to try to make this guy into a 1. So I have that nice diagonal, which is a 1. Okay. So what am I going to do? I'm going to take the third row and I'm going to divide it by 3. Okay. And he's going to stay in the third row. Okay. So now if I do that, let's just go put a 1/3 here. 1/3 times 0 is 0. 1/3 times 0 is 0. 1/3 times 3 is 1. Okay. And then now we can go negative 9 divided by 3 is negative 3. And now we have 0, 1, negative 1/5, and 13/5. And on top we got 1, negative 4, 0, negative 7. All right. And there it is. Okay. And you can see how you have that nice diagonal here, 1, 1, 1. Okay, and this is what we call a row echelon. Echelon meaning the step. You see how it like a stepping staircase there. But you want to see how these are zeros here, and we got that nice diagonal here. So now remember, the first column represents the x, the second the y, and the third the z. So this one over here tells me that z is equal to negative 3. Which is nice. This tells me x minus 1/5 of, I'm sorry, this is my y. So y minus 1/5 is going to go ahead and equal 13/5. Okay, equals to 13/5. And the last one on the top, you have 1x minus 4y is equal to plus 0z. I just put equals to -7. Okay, and that's it. So now with this guy, I can go ahead and put it here and solve. So y minus 1/5 times z times -3 is equal to 13/5. Okay. So negative times negative becomes a positive. Y plus 3/5 is equal to 13/5. And then of course, when I do the math, I bring it across. Becomes a -3/5. You get y is equal to 10/5 or is equal to 2. So z is equal to -3, y is equal to 2. Now, I can go ahead and find the last one. So we have x minus 4y minus 4, and we said y is 2, is equal to -7. So we have x minus 8 is equal to -1, and I'm sorry, -7. And then when you solve it, you're going to get x is equal to 1. And that's your solution. X is 1, y is 2, and z is -3. All right. So you can see it's a bit tedious, but hopefully that makes sense. But how do we start? We started with the top. Make this a 1, then make these 0. Then make this guy a 1, and then this 0. And then lastly, make that guy into a 1. It's a bit tedious, but not too bad if you go nice and slow. All right, guys. Hopefully that helped you out. See you next time.